Hello everyone, welcome to my channel Euclid Mathematics. Today I'm going to explain here some of the examples from CSIRNET exam which are more important for different competitive exams from groups and subgroups. So if we have some clues like order of group is given or group is a cyclic, non-cyclic, abelian which is given. So by using these clues, how one can get the subgroups of a given order. So using some different properties, we can find it easily. Okay. So in my today's lecture, here I will explain to you all groups and subgroups and how to find their subgroup of different order. So let's get started with example here. So if I am having example here, if G is an abelian group and order of G is 24 element. Okay. G given abelian group. Okay. This property is very important here. Okay. And G is a 24 element. Then number of order 6. Then G has a 24 element of order 6. Then how many subgroup of order 6? We want the subgroup of order 6 here. Okay. Now, if G is abelian, then all subgroup it need to be abelian, because group is abelian, all subgroups are abelian. Group cyclic, then it's all subgroups are abelian and cyclic. Okay. So you can see it here. I am having order of G which is a 6. Okay. G has 24 element of order 6. That means order of there exists 24 element of whose order 6, and we want the subgroup of order 6. That means we want the group where that G is isomorphic. Okay. If order of G is a 6, that means we have to consider same group. Okay. I consider here as a H whose both order are same. Okay. And then we have to find out which one of the group is isomorphic to our group of order, subgroup of order 6. Okay. So you can see it here. I consider order of H as a 6. If order of PH is a 6, that means order of we want the subgroup of order 6. Okay. So I consider that subgroup it is the H. Okay. I consider H as the subgroup because we have to guess first of all what is the possible group, what is the possible element of order exist. Once we come to understand, then by using the properties of a cyclic, abelian group and their other properties, we easily can say that where that group is isomorphic. Okay. So order of subgroup is a 6. Now let's verify where that subgroup is isomorphic. Okay, we know that if group of order 6, then that group is isomorphic to either Z6, which is abelian or cyclic group. Okay, Zn always abelian cyclic, or which is isomorphic to S3, which is a non-abelian. Okay, so one of the group is isomorphic to 6, but we have given G is an abelian group. If G is abelian, then order of H, which is a 6, which is isomorphic to Z6. That means a group of order 6, which is isomorphic to Z6, not a S3. S3 is a non-abelian. Okay. Permutation group is non-abelian. Then if you wanted to see, you can see it into my previous video. I explained the permutation group and how it is abelian or non-abelian or cyclic or not. Okay. So you can check it from there. So I got it here. Group of order H, order of H is a 6, which is isomorphic to Z6. And we know that subgroup of Zn is a tauion. And I explained in my previous lecture how to find subgroup of Zn. Okay. So I'm having here H is a abelian and which is isomorphic to Z6. Okay. And H is a cyclic group. Okay. And Z6 is a cyclic group. And we know that for finding subgroup of a cyclic group, which is number of cyclic group of order D in G, which is the number of element of order D in G divided by phi of D. Okay. So you can see number of element of order 6. We want it here. Okay. Keep in mind, we are working for the subgroup of order 6. Okay. So we are working for subgroup of order 6 here. Then number of cyclic subgroup of order 6. Then total element of order 6 in our group G. Okay. So how many elements are there whose order 6 and total divided by phi of 6? Now let's verify. Our property it says that. Okay. So number of element of order 6. Number of cyclic subgroup of order 6 we want it here. Okay. And number of cyclic subgroup of order 6, it says that number of element of order 6 divided by pi of 6. But in our example, we have given number of element of order 6 is a 24 element whose order 6. Okay. So number of element of order 6 which is a 24. Okay. And phi of 6 which is a here. Okay. Number divided by phi of 6. So phi of 6 by using Euler phi function we get it to here. Okay. That one is quite easy. If you wanted to know how to find Euler phi function, you can check it into my previous videos. I explained there for finding Euler phi functions. Okay. So 24 it remains same. So phi of 6 it is a 2. Okay. So divide 24 by 2 it is a 12. Okay. That means I got it here. The number of element. Okay. Okay. This is a group and 24 element. Then how many subgroup of order 6? Total subgroup of order 6 I found it here. Total 12. Okay. So I hope so you all have understood how to find out the subgroup. Okay. By using given some properties. And element of order it is here. Okay. So I got the cyclic subgroup of order 6. I hope so you all have understood my today's lecture. For similar videos, you can check it into my playlist. So if you have doubt, comment me in a comment section. I'll upload similar videos as per your doubt and difficulties. So thank you everyone. Thank you for my today's lecture.